with the internet. Great job, everybody. Good start. Okay, so just for a background, you heard a little about me in our introductions of instructors. My name is Madicken. You can always ask my name again. It's not the easiest. It's Swedish. Thanks, Sweden. And I am at the National Center for Supercomputing Applications at the University of Illinois, Urbana-Champaign. And my background is in nuclear engineering. I simulated nuclear reactors and radiation shielding environments for my dissertation. So I used Python a lot, but I also used Git a lot. And so today we're going to go through using Git for a collaborative paper process because I think Git is super helpful for doing code and code review, but we can also use it for our scientific workflow and making sure that we have really transparent review process with our collaborators. And so we're going to go through that a little bit today. So I think all of you had an assignment before the school started to review some Git basics. We're going to go through these really quickly, and then we're going to get into a little deeper of some Git things. So in this first section, we're going to talk about Git config, Git clone, Git init, Git add, Git commit, Git status, and Git log. So first of all, when we are version controlling with Git, we want to make sure that authorship is clear, right? So when we go through and we start adding these snapshots of our repository, we want to make sure that everybody knows that I made this commit, my collaborator made this commit. It's a way that we ensure that changes are tracked, but that authorship is clear also. So we can set our Git options and add these authorship options using Git config. The first way we can do this is with git config minus global. And so what minus global is going to do is going to set the git config options for our entire user profile on our computer. Then we can set user.name, and then we can type our name. So I'm going to do Madicken Munk. I think your user machines are going to be associated with your group, so you're not going to have to update these until the very end of the lesson today. So we can set our global username like that, and then we can check that it has been updated with git config minus list. Now I have a bunch of git config options, so this is going to print a bunch of stuff to the screen, but we're going to be able to see that the username is in there if I scroll up. Here we go, username Madicken Munk. We want to put the username in quotes because there's a space in it. And so when we are using things that have white space, it's really helpful with Git to put it in quotes. So also we want to set the user email. And so we can see in my Git config options, there's some user settings. The second two down, there's my name, and then there's my user email. Git config, we can set lots of different things with Git, but right now we're going to be worrying about username, user email, and our core editor. So I mentioned, first of all, that git config, we set this global option, which sets for our total user profile. We can also set, we can kind of change the settings of what we're modifying in Git. So let's say I am version controlling something at a national lab, and I have a different email associated with my work at this national lab. I might want to change my user email, but only for a local repository and not for my global user settings. So I would say git config minus local, and this has to be executed in a Git directory because it's going to be modifying something in our Git directory. I haven't made a Git directory yet, but I'll set the user email slightly differently as an example in a second. So we can set a local option, or we can set the system. And this is going to set it like much farther down on your computer outside of your user profile settings. I would not recommend setting a system-wide. And so also Git will prefer and it will override options. And so local will have the highest preference, then global, and then system. So on our machines, we want to set these particular user settings. So then when we set these user settings, then the next thing we want to do is create Git repositories. There's two different ways we can make a Git repository. We can make an empty directory on our computer, and I'm going to make an example directory called dissertation. Then I'm going to move into it, and then I can type git init. This is a way that I initialize my repository. But first, actually, I can say one of our most used statuses that we should be using in Git is git status. And this will tell us what the status of our repository is. If I haven't initialized or I'm not version controlling a directory, Git will throw an error, and it looks like this. So if we have some useful work that we want to be tracking, we then set it. We now know that this is not being tracked by version control. So then I want to type git init to make sure that this is initialized properly. Okay, so now I initialize this dissertation repository in my folder on the summer school, or on the school. Okay, so now I can say git status, and now it tells me a little more information. I'm going to go into branches a little bit later, but it says on branch master, there's no commits yet, and there's nothing to commit, which means that there's no files in this folder that Git recognizes that need to be version controlled yet. We can also do git clone. So when we are creating Git repositories, we want to make sure that all of the Git repositories live alongside each other, and we don't nest Git repositories in subdirectories of other Git repositories, because Git will track everything from the initialized directory and below. So actually, if I go back into my dissertation repository, if I ls in here, I don't see anything, but if I do ls minus la, I have this .git folder. This .git folder is what Git uses to track changes and identify different snapshots of the repository that have been important to me. So I mentioned that we have this global and local Git config settings. What those command line options do is actually modify a file. So if we modify git config local, so I'll change my user email just so you can see this. And then I'll change it to my Illinois address instead. Then I can look at my options with list, and I can see there's two user emails that end up showing up. There's first is my global one, but then farther down I can see my local. So in this Git folder, we have, if I look inside this hidden Git folder, there's a bunch of different folders and documents that Git is using to track our repository, but there's a config file in there. So if I cat this Git config file, I can see that the user email in this repository is changed. If I go back out and if I go back out of this repository and I go into a different one, let's say, so in this I have our Git lesson that I'm teaching from. And if I look in that repository, and then I if I look at that, it has like some information on remotes and things like that, which we'll get into, but it doesn't have the user email because I didn't set the user email in my local Git config options. So I'm going to go back into my dissertation repository. And so I said that there's this local user email, but our global one is stored somewhere else. And that's actually in our home directory in a git config file. I'm just going to open it. I'm going to cat it. And so we have a bunch of other information, and if I scroll up, I can see my user name and my user email that are defined on the global level. Okay, so now I've created this repository using git init, and I am not in the right dissertation repository, actually. Sorry. Okay, great. Now we're back in the right one. So we can also create a new repository by cloning. So the git init option, we don't need to have internet access. The git can be, we can version control our files without the internet completely if we want to. Git itself doesn't need GitHub or any access to the internet to be version controlling files. However, if we want to make a copy of an existing repository that exists on GitHub or another remote hosting service, we can use git clone. So I have my GitHub user profile opened, and okay, so I can see here, this is my user Munkum, and this is the matplotlib repository that's associated with my user profile. We can also go up to the matplotlib main profile, or the main repository, and we can copy this URL, and then I can say git clone, and then that URL. And then what Git does is makes a new directory associated with the with whatever the Git repo name is, and it will copy it into that file and copy all of the references in the version controlling. We can also change this. So I have a git clone with a URL. We can also add another argument at the end, and we can name a folder. So if, for example, you think that the name is really long and it's going to be hard for you to navigate into it, you can create a shorter repository folder name. So you could say git clone and then matplotlib.git and then say like MPL or something like that, if that's going to be more helpful to you. The one thing that makes this a little, that I would caution you against in doing that, in renaming the remote folder, is it might be harder for you. It might be hard for you to then remember exactly what the remote URL is if you don't know how to get to that. But we'll get to that in a second. So matplotlib's taking a long time to clone, so maybe this was not the best clone example for this part of the lesson. But I'm just going to let it kind of, I think I can, so I'm just killing the clone, but you can see that that was what was happening. So the example is there. Okay, so if I'm in my dissertation, I was actually cloning it into my dissertation repository, which was actually not super smart, but since I killed the clone, you're not going to see it. So this actually would have been a very bad example. I should have moved up into ASAP, APAC, and then done git clone from here like this. Because I mentioned that you should not have nested folders of version controlling, and I just did an example of doing that. So nice, good job, me. So let's go into dissertation again. And so we have a life cycle of a file in a Git repository. So if we make a new file, I'm going to make a new file called introduction. And I'm going to make it a markdown file. But we can actually version control tech and things like that. My entire dissertation is version controlled in LaTeX. So, okay, so I now, because introduction.markdown didn't exist, I created this new file called introduction.markdown. Now if I do git status, I can see that Git sees that there's an untracked file, and if I want to add it to my repository, it's going to tell me to add it. So this is a file that has never been committed to my repository, and a commit we can think of as like a snapshot of a place and time of our repository that is interesting to us. So it's saying, okay, well, there's this file I recognize, but this file is not one that has ever existed in the history of this repository yet. So if I want, I can git add introduction.markdown, and then I can say git status. Okay, now this coloring changed from red to green because it's saying there's changes to be committed. So before I had an untracked file, I've now moved that untracked file into something called the staging area for Git. The staging area is where we add all the files that we think that we want for a particular commit. So if you're doing like a fix and you need to change two different files that are associated with that fix, and you want them both associated with that commit, you can add them in this process. And so adding is where we're like staging these files for commits. We're saying these are the files we want to add to the commit, but we're not committing yet. We're thinking of saving them. Okay, so then I can say git commit. And so this is an empty file, but I can still commit an empty file to my repository because it exists as a file in this folder. So if I say git commit on its own, what Git is going to do is going to open my default set core editor. So I was showing you some Git config options a little bit before, and in this lesson and in this workshop, we're going to be using Atom as our core editor. So first I'm going to show you how to set the core editor, and then I'm going to show you what it looks like when we execute git commit with Atom. So the way we set our core editor, big, then we say core.editor, and I linked in the lesson notes, and I'll link them to you later. You can change your core editor later on, but for this lesson, we're going to be going along with Atom. So we want to set the core editor, and then in quotes, we can say Atom, but we also need to add an argument of weight. And this is because if we don't add the weight, then as soon as Atom opens, Git is going to think that I'm committing the file, but I'm not actually changing the file that's telling me about what the commit is. It's going to open a file that we want to associate with a message, so that we have a message associated with this unique snapshot of our repository. And that way, when we're looking back in our history, we know this change is associated with this like number that we're going to see is associated with these changes that we've described in this really descriptive message. So we have to have this weight option. I can check also what my core editor is. And let's see here. So I have the Atom -- weight already set on my machine. So now let's try and git commit this, because we've added it to the staging area. I want to add this introduction.markdown file and then commit it. So I'm going to git commit. Okay, so now my machine is opening Atom as my editor, and this is kind of hard to see, I'm sorry. Let's see if I make it bigger. Can you see that? Yeah, I'm sorry the coloring is, I didn't think about changing that. But okay. So because we've set our core editor, Atom is going to open our editor, and it's going to open a particular file that's located in that .git folder that I showed you before. And it's a file called git commit edit. It's a commit edit message, and there's some comments in here that's saying that Git's trying to help us with. So the nice thing about Git is it's like very helpful, and it tries to tell you what you're doing as you're going through the exercises. So we want to enter a commit message for our changes, and so the first line we want to make is a short, very concise message that describes our changes clearly. We want to ideally make it less than like 50 characters if we can, and also you want to make it in the present tense. So I might want to say add introduction.markdown or initial commit. I don't want to say adding because this is like a very this is the standard way that Git operates, and this way we're staying with, so Git will automatically create merge messages sometimes, and so we're staying with the standard of the way that Git was designed. So I'm going to say, let's say, add initial document of dissertation. And then also if we want, we can go down and do a double line and then give a much longer description of what we're doing. I think because I created an empty file, there's no reason for me to give a long description of what my given message is. But if you're making a really big change that's going to be helpful for people when they're looking through the history, you can put some information here about which files you changed, why you felt it was helpful. But I'm not going to do that. I'm just going to leave it as this initial commit. So now I can save it. Oh, actually, so I'm not going to save it yet. I'm going to show you. So because I haven't saved it yet, Git is now, I have like this, I don't have a prompt in my shell, and that's because Git is waiting for me to save the file in order to continue on with git commit. So Git, I can't actually do anything in my editor until after, in my shell, until I've saved something in the editor. So now I'm going back to Atom, and I'm going to save this file. And then I'll exit out because we don't want to like continue accessing this file anymore. And then if I go back to my shell, I can see, okay, I am on this branch called master, which we'll get to again later. And then there's this special thing in brackets that says root commit, which means it's the first commit in our repository. And then there's a number after it. Well, a series of letters and numbers, which is our git commit hash. And this is the unique identifier associated with the snapshot in our repository. And then there's the message that I put in Atom. Okay, so now we've moved a file from untracked to the staging directory, and then we've committed it. And so now if I do git status, the file says on branch master, nothing to commit, working tree clean, which means that the file introduction.markdown looks exactly the same now in my working space that it did at my most recent commit, which is this 6762C59. So it's saying these match, there's no difference in your working directory and this most recent commit, and so the working tree is clean. So I think I'm going to have you do some exercises now. Let's make sure we've covered all the.
Use like git commit just minus m with the.
Yes. Okay. So this is. Oh, that's a great question. Okay. So I just showed you a git commit that pops you straight into editor, right? But we actually don't have to go into an editor if we don't want to, especially if we're not going to do this longer git commit message. So let's say I modify introduction.markdown. So I will say Atom. So now I've opened introduction.markdown in Atom, and I'm going to say okay, so now I have a first sentence of my introduction of my dissertation. Clearly, I'm a great writer. This is a very stimulating sentence that people are going to want to version control through their through their dissertation. Okay, so now I've created that file and I've saved it. Now, if I say git status, I have a modified file. So before we if I scroll up, when we created that file, where are we? We had an untracked file, and it said introduction.markdown was untracked. Now we have a modified file. So now what Git is telling us is, okay, you have this change. So what your working tree, your working directory, looks different than the most recent commit you've made on introduction.markdown. I see a change and I recognize it. So we can add this just like we did before. So we're moving it into the staging area. We move files into the staging area the same way if they're untracked versus if they have been modified. So we're going to git add introduction.markdown, and then we can say git commit, and we can say either minus message, or we can say -m, which means I'm going to commit with a short message on the command line, and I'm not going to enter into my Atom text editor. And so git commit -m is much faster, especially if you don't need to do this longer commit message. So I'm going to say so now I have now I don't have this the same echo back that I had from Git before. Before it said master and then root commit and then a commit hash in these brackets, right? Now it just says master and the commit hash because I'm not making the initial commit in the repository. This is now a commit farther down. And I have obviously a very cool commit message associated with my introductory sentence. So now I have two commits in my repository. The way that we look and we can see the history through our repository is with git log. So git log will show us a lot of things about our repository. First, we have the commit and then the really long hash. So above here, when I committed master, I got a really short echo back of the hash. And then, but just below it, I can see the full hash. And you don't have to, like, this is useful to look at in the Git history, but when we're navigating around in the future, using a short one with at least the first 7 characters is good enough to identify any snapshot in your repository. So this number, this hash here matches this hash here. And so we can see, okay, in this particular repository, I have my name and my email, my new email, mmonk2 at Illinois. And then I have this echo back that says head pointing to master. And then I have 2 different commits. So I see 2 different numbers here. What head is what we're looking at in our repository. That's a good way to think about head. So head is a pointer to what we're looking at in our repository. Head can point to either a unique commit or it can point to a branch. In this case, head is pointing to a branch called master, which is our default branch that Git creates when we start a repository. There's many, so we're going to work with branches in a little while, but right now we only have one branch called master. And head is pointing to that branch, and head is pointing to the tip of that branch. And master is also pointing to the tip of that. The most recent commit in that series of commits, in that list of commits here. So git log is really long, and especially if we have something like matplotlib that was taking me like 5 minutes to clone, we maybe don't want to go into a super long git log, right? Also, this only has 2 commits, but we might fill up our buffer, and so we have to scroll between it. We have to scroll a little bit in our log, but we can do something shorter. We can say git log --1 line, which will show us a shorter commit hash and just the commit message. Yep.
Is there a way to get it to show which files have been modified?
Yes, there is. So we can say. Okay, so I think, so it's a name only, but so I'm trying to think, I don't do it in the log. So it's git, so this is going to compare my, so I'm going to say head, which is what I'm looking at now. And then I'm going to compare it to the commit just before that, or the first commit that I did. So I'm copying, so I'm comparing what I'm looking at now to the first commit I made in my repository. And git diff is the way that we look at how, like, what has been changed. So now I'm just comparing 2 different commit hashes. So if I have a lot of files in my repository and I do the very first commit and where I am now, that might show a lot of different files. But we're only going to have one, and then we can say ---- name only. I think this is going to work. Yes, okay, great. So now I added this additional flag, which is kind of wrapping around. So it's ---- name only, and this is going to show me just the files that have been changed in between these 2 commits. I think if we can try it, but I think if we just say 1 commit hash, it will default to comparing it to head. So let's see if that's true. Yeah, okay. Yes? Oh, awesome. Like this? Oh, cool. Okay, so this is like a longer one and it shows with each commit. That's really cool. Okay, I like that. I have not used that, so. Yeah, super cool. Yeah, okay, so you can do this. And so this actually looks like what it's doing is showing how many lines also are in each file with each commit. So our first commit, there's 0 lines that were committed in introduction.markdown, but there was a file made. And here in the next commit, it said we added 1 line. And Git will default, when it's showing these things, it's going to show how many line diffs that you have when you're going through. So we're going to see later when we're adding more complicated histories, you're going to see pluses and minuses, and it's going to show you that. Okay, so now we're going to go into exercises.
What was the last command again?
Oh, it's git log --stat.
Thanks.
Yeah, that's super cool. You have taught me something today, everybody. That's not in the software carpentry Git lesson, I can tell you that. Okay, so now we're going to do an exercise together with our partners. And I will put it up here. Okay, so in here, I didn't realize you had some config settings. Can you read these? Or actually, I'll put the link to the exercise in the Zulip chat if you can't read these. Would that be more helpful to people? This is good? Okay. Yeah, I'll just put it here. So now it has everything. Okay, so you don't have to set the config settings, but I want you to check instead that the config settings are set in your global user profile with a username, a user email, and also that the core editor is set. And that if the core editor is set, that the -- wait option is also set with Atom. Okay? So we'll do this for the next few minutes. And so if you're going through, use the stickies. If you get stuck and you need some help, put up the pink sticky. If you are done, put up the blue sticky. And if you're in progress, you can put up the yellow sticky or a green, whatever color you think it is. No, you want to follow all of these. This is the first exercise for the first section, yeah. Okay, yeah. Some of them will go really quick, don't worry. Okay, everybody, I'm sorry for the confusion. I think we should change the username and email on each one. So I said don't do that, but let's do it because when we push our changes up to GitHub later, GitHub does need an address that it's going to recognize associated with the user account. So one of the partners is going to have to choose who to put your own credentials in. So put your name and your email. And then later, you're going to have to sign into your GitHub account, not the other partner's GitHub account. And we're going to push those changes up to that person's GitHub account. Okay? So in this exercise, also change the name and email, because otherwise we'll have some trouble pushing. And I want to make sure that's smooth for all of you. Okay, so in the first part of the section, we went over the basics of adding and moving a file from either unstaged or from either untracked to modified, untracked or modified to staged for commit to committed, and then back to a clean working tree, which meant that our what we were looking at in our repository matched whatever the most recent commit was. That's like a clean working tree. So now we're going to talk a little bit about if moving files around in our repository, because Git recognizes things by file name, moving things around or adding them and unstaging them if we realize we need to make another change, or removing their changes completely. So we're going to go over these 4 commands. We already talked a little bit about git diff, thanks to somebody's very good question earlier. So we'll continue a little bit with git diff, but you already have a preview of that, which is pretty cool. Okay, so I'm going to be in my dissertation repository again, but don't type anything yet. I have an exercise for you after this in a little while. So somebody asked a very, very good question at the end of the break, which was so they commented that they usually like to add and commit everything all at once. And this is it's useful if you are only changing one file, or if you know that everything that's been changed is going to be committed and you want it to be. But I'm going to show you how we can have multiple changes and we don't have to commit them all at once by using the staging area. So I'm going to do a little example of that, and then we'll unstage them throughout this example. So I'll check what's in my repository. I have this introduction file that has that really stimulating, riveting first sentence. And I can see that I'm on branch master and my working tree is clean. We just talked about the working tree in the little review before this session. So now I'm going to make 2 more files that I want associated with my dissertation. So I'll make a new file called results, and I'll make a conclusions, and maybe I'll also make I know you already edited an authors.markdown in yours, so I'll do that also. So now I have, if I do a git status here, I can see that there's 3 untracked files that exist in my repository. So I know Git is telling me these are I've never seen these in the history. They're untracked. If you want to add them, you can do it with git add and then whatever the file name is. So so I could add and commit these all at once by doing git, is it git commit am? Yeah, okay, I think so. minus AM, which means I'm adding all of them with the minus A. And I'm going to add a message, and then I can add a commit message. But I'm not going to do that. I'm going to, because I have actually realized, okay, actually, authors is kind of separate from my dissertation. I'm probably the only author, but I don't need that to be associated with the commit that I'm going to make with my conclusion. So maybe, or actually, let's see. So we can do git add minus A, and that's going to add all of the files that I just made to my, oh wait, do I have to do a capital A? Yeah. I can do minus all or capital A, not small a. Wait, what?
Single dash.
Oh yeah, thank you. Single dash minus A, or double dash minus all. Okay, then I can say git status. Okay, now it says, okay, there's all of these files that you added to your staging area. So if I had done git commit minus AM, it would have added all of these with the minus A, and then I would have the message associated with it also. But now I'm saying, okay, well, authors doesn't really go along with my dissertation, so maybe I want to unstage that. I don't want to add that in my commit. So git actually gives us a really useful message here saying you can say git reset head file to unstage. So I'm going to move this file, instead of moving up into the staging area, I'm going to move it back into my working tree. So I'm going to say git reset head, and then authors. Now if I do git status, I can see that there's 2 files in my staging area and 1 file that's not in my staging area. This is in my working tree. If I say, so also, if I do git status right now, git diff, sorry. So we talked about git diff before that with the name only. We could look at that, or we could compare diffs of different messages in the log. So I can say git diff, and so since I haven't changed any files or anything like that, it's not going to show anything. However, if I modify, so let's say also I'm going to add another thing to my introduction. So I'm going to add obviously a great sentence again that I'm adding here. Okay, so I'm going to save this, and now I can say git status. Okay, so now I have a modified file introduction. If I do git diff on this, I can see what has changed. So so this is something that is helpful to remember for when you're writing papers outside of code, is that GIF does things by line differences. So if you don't have a hard wrap on your lines, you could write an entire paragraph, and when you do a git diff, and like maybe you add 1 sentence to the paragraph, when you git diff it, if those lines aren't hard wrapped, that you're not doing a new line at the end of every certain character amount, it's going to print the whole paragraph in the git diff. And so that might be really hard to see what diff is happening. So actually, if I go back to the file, and let's say I'm like, okay, actually I would prefer that I'm just going to leave the thing about the simulating radiation. I'm going to put the neutrons on a new line, and because I know that this diff thing happens. So now I'm saving it again. Now if I say git diff, it's okay, because I added a new line, it's now it's recognizing this as a change also. But if you didn't add the new line, then it wouldn't show that as a diffed thing. So now it's showing that there's 2 new lines because I modified this one with the new line. But okay, so now if I do git status, I can see that I have this modified file, and I also have these 2 files that are in my staging area. I want to add introduction also because I'm just modifying my thesis right now. Okay, so now all of those are there. I have 2 new files that are in my staging area, and then I have my modified file, introduction. Now I'm going to git commit -m like we talked about, and okay, now if I say git status, those moved, but authors.markdown never changed. So the staging area is very helpful for us to make thematic changes in Git. We can then make multiple edits at once, and we can choose what files we want to add and put in our snapshots each time. And so you can choose however you want to do this, whatever process makes sense to you. Git is super powerful, and so you can kind of change your workflow however you want. But I kind of wanted to talk a little bit about why the staging area is useful for me in my particular workflow. Okay, so I have this file authors.markdown that then I unstaged. So I had added it before, and then I unstaged it. I'm going to change it, and I'm going to add my name to the authors.markdown. And then okay. Okay, so now I've saved it. And it still says that it's an untracked file that has not been added yet. So now I'm going to git add it. Okay, so now I realize, okay, well, authors.markdown doesn't really, like writing a sentence for authors.markdown is kind of impenetrable. Like maybe I just want a list of the authors and I just want to put a bullet point with my name. So I can either change it or I can add those changes again. Or what I can do is I can unstage it and then delete the authors.markdown file and then make a new one. So I'll first unstage. Now I'll check with git status again. Now it's saying it's not in the staging area. It's not to be committed and it's untracked. Oh, actually, so first I'm gonna commit it and then I'm gonna make another change to it because I can't do this with an untracked file. So just remember what I was saying, and then we'll quick do the example. Because this deleting changes only works with files that have already been in your Git history. So in brand new file, you can't. The way that you would delete it is you don't have to use a git command. You can just say rm file because Git has never tracked it. So there's no reason to ever use Git to like go back to delete the changes out of that file. So now I'm going to commit it. Okay, now I'm going to add, let's just say I'm going to add my research advisor instead. So Adam. Okay. Okay, so now I have a file that's been modified as opposed to never added to my working tree. So now I can actually delete changes out of this file. So I showed you just before how to unstage things. We can also do git checkout -- file to remove the changes from the file completely. So this was an author's file. I know my advisor's not an author. She's a reviewer of my dissertation, but she's not going to be on the authorship list, right? So I can say git checkout -- authors.markdown. Then I can say git status, and it'll say on branch master, nothing to commit, working tree clean. So I brought back my version of authors.markdown back to the most recent version that was in my, that was the most recent version that was committed with this particular command. So we can also move files around. So I have an authors, yeah? So actually the dash dash, so the dash dash is a little special. It is not that. The dash dash is what separates a git command associated with the repo and then like file names. So we could do a whole list of files. So I only had one that I wanted to unstage with authors. But if I maybe had like 3, I might have authors.markdown and references.markdown and contributors.markdown or something like that. I would say git checkout -- and then the list of each one of those. So the -- helps separate the arguments from the command itself. And specifically, it's like useful in things where you're going to have like a list of different files or something like that. Does that make sense? Yeah? Okay. Cool. I want to just make sure there's no. Okay, great. And also just remember if need me to stop or review something, just put up your pink sticky. Also, you are welcome to raise your hand and ask like you just did, but I want to make sure that as we're going through, everybody's following. Okay, so we can also move things around. So let's see what's in my repo right now. Not Git LS. Okay, so I have an authors, a conclusions, an introduction, and results. Maybe I realize that I'm getting way ahead of myself with conclusions. I don't actually have anything to conclude because I haven't even done my analysis yet. So maybe I want to move conclusions.markdown into analysis.markdown because there's nothing in that right now anyway. So I'm just going to move it and see what happens. So we can use git move. So this is just like the bash command mv, except it's associated with git. So we can do git move, and then we're moving conclusions.markdown into analysis.markdown. Now let's see what happens when we do git status. Okay, so git status, now this particular command did something very interesting. We didn't just change the file. Yeah?
Why isn't there two double dash between MV and the two files?
I think we actually could do that. Do you want me to try it?
Sure.
Yeah.
Is the dash the difference between like positional commands and like named commands or like arguments?
Yeah. So like it's the things that are associated, like the arguments that we're passing into the command of like, so we're removing the particular file from when we did git reset, right? It was git reset that we used it. Git checkout. So because reset does a file, checkout does like a tree. So okay. So git checkout minus will separate whatever things we pass into git checkout and the command itself. And so we probably could do this with move. I can try it if you want to, but that means I'm going to have to unstage. And so you're going to see a kind of funky unstage, which is going to be kind of fun. So okay, now it's saying git reset head to unstage, but I have two files now. I have conclusions and analysis that I need to unstage because we renamed conclusions.markdown to analysis.markdown. So if I ls in here, I now don't have the conclusions file. It's been moved to analysis, just like the standard bash command. So let's see, git reset head. So now it's saying unstaged changes after reset. So it's saying, okay, the conclusions.markdown file was deleted. And so that now has been unstaged. But so we can see now that this conclusions.markdown was deleted. So now we can say git reset head analysis. Okay, so now we have a new file analysis that was created in this process. We can say git checkout minus conclusions to undelete it now because we don't want it to be deleted. And we don't want the analysis.markdown file because we now have the conclusions one back. So we're going to just delete it because it was a new file that was never created. So we can say rm analysis.markdown because we now have returned back to the conclusions one. Okay, so now we can say git status. Let's try git move with the minus. Actually, I'm betting that this is not going to work because we want to move from and to, and the other one was like a list. Like we could pass a list of commands that were all doing the same thing. But let's see what happens. I'm not sure that this is going to work because we wanted the same operation on each file when we did the checkout, git checkout minus file. Each one of those files was going to be checked out if we had passed a list to it, whereas this is we're operating and we're moving one to another place. And so there's a different operations on each one because we deleted the conclusions file, but we're not deleting an analysis file, we're creating an analysis file. So let's see what happens. I'm curious what's going to happen here. Oh, it worked. So never mind. I have never tried that with move because usually I'm just doing like if you're not like passing a list or something like that, it's not necessary to do the minus. Minus is more powerful when you have like a set of things that you're passing into one command. Okay, so we've renamed it. So now we just saw a very complicated git reset with this move command, right? So also, this basically combined 3 different commands in one. We moved conclusions.markdown to analysis.markdown. Then we added the deleted file conclusions, and we added the file analysis to the working directory. So that was 3 commands in one that's shortened by using git mv. So that's like really helpful to us. So now I'm going to commit that and say, let's see. Okay, so that's git move. We can also do git rm. So we can also remove things out of our directory. So now, okay, I realized actually I can't even do analysis until I have data. So I should probably just delete the analysis file completely. So let's remove it. So we can say git rm analysis.markdown. And now the same thing happened. So instead of having to do 2 different commands, we first did rm analysis.markdown and then git add analysis.markdown. We git rm combined both of those and added that to that deleted file to the staging area for us. This is also extremely nice because if we, for example, have a whole list of files that we want to remove at once, we don't have to then delete each one and then add each one to the staging area. On top of that, some of you might have noticed that we can do tab auto-completion in the shell, right? Well, once we remove a file, we can't use tab auto-completion, which means we have to hand type out every time we put a deleted file into the staging area. And so git rm helps us like avoid that. Yes?
If you want to delete all of the files in the directory, is it rm-r?
I have not tried that.
It's just a recursive.
Yeah, I mean, I suspect you probably could. Although if you want to delete all the files in your Git repository, you could just delete your Git repository. Yeah. You can. It works. Yeah. Right, right. Right, but if you don't have any folders in your directory because we didn't have we don't have any right now in this particular directory. But yes, with folders you would need to include the recursive. Yes. Okay.
If you change the tracking from changes in a file, that's either checkout or reset, I'm not sure. And if you then pull from your repository, does that write over the changes that are still currently in that file? Or does it make a second?
Okay, so you're saying if you have something in your working tree that is not committed and you pull from a remote?
Or if you reset a file, so it doesn't even come up as modified anymore.
If you reset a file, those changes are gone completely.
Okay,
like you won't.
It's not
even changes anymore that you can ever refer to because you've removed those changes completely. Okay, so did everybody hear that question? That was really good. Yeah. Okay, so I'll repeat it. So her question was, if you use the git checkout -- file, which then removes the files, the change file that says like change it, that says you can add it, so it's in the working tree, and if you then reset it so it says the working tree is clean, and then you pull from GitHub, which we'll talk about in a little bit, but let's say you pull, like you incorporate some new changes into that branch with this, into your repository with that, will you never be able to get those changes back? And the answer is actually a little bit simpler, which is when we do git checkout on that file, we delete the contents of that file that we modified completely, because that has never been put into our version control history. We recognized that file had been changed at one point, but then we said, actually, I'm checking out this file and I don't care about this anymore. So it's true you would never be able to get that back if you incorporated changes from another repository, but also you can't get those changes back even if you don't pull down another repository unless you have committed them or something else. Yeah. Yep, no problem.
Could you just expand on what you mean when you get to check out the file?
Yes, okay, we're gonna go into git checkout in like another exercise, so don't worry, so git checkout, yeah, we will talk a little bit about that because we can do git checkout on a file or on like a branch or something like that. And so we're gonna go into the difference between that in another exercise. Yeah?
So just to clarify about the removing files and the autocomplete,
Yeah.
I've had that issue a few times where it's like I've deleted a file just in the file system
Yeah.
and then I go into the Git and then it's
Yeah.
like
Do you-
actually adding into the staging area.
Yeah. Do you want me to show you what that looks like? I'll show you what it looks like really quick, okay? So now I've unstaged that commit, and now I'm going to check out. So I'm going to go back to the previous working state, right? Okay, so now analysis .markdown exists, and I haven't deleted it yet. Let's say I don't use git rm, and I just use rm, like you're suggesting. Now I say git status. Okay, now it says it's deleted. In order for me to commit these changes, I need to say git add analysis, but I can't actually autocomplete. Like right now I'm hitting tab because it doesn't recognize that the bash shell doesn't see a file called analysis. So I have to hand type that out, which is annoying. Now I can say git status. And now it looks exactly the same thing as when I did git rm. So git rm and git move help do shortcuts when we're doing these changes like this. So we don't have to keep adding a bunch of things to the staging area that Git knew we probably were going to add anyway. Does that make sense? Okay. So now I'm going to commit that. Let me see. Or actually, so one thing I also should show is oh wait, no. Okay, I'm going to commit this. And then I'll show you something else. And I'm not going to say deleting. This is something I talked about that you want to use present tense. So I'm going to say delete analysis because I have no analysis. Okay, so now also git diff, I mentioned, compares whatever is in our working tree to our most recent commit. So let's say let's see what's in here. Okay. I'll add maybe something to my results. So I'll say Adam. Okay, so. Okay, so now I'm saving that. I'm clearly like an overzealous PhD student. I'm writing my dissertation before I've done any of my work. So, so now we'll say git status. Okay, so now I can say git diff, and I said this is comparing whatever is in your working to your most recent commit, or to what that pointer of that most recent one on your branch. So results. Okay, and then I can see this sentence, right? And it's telling me, Git is saying, okay, I've added this sentence to this. Let's git add this. Now if I git diff, Git doesn't show me any difference. And that's because this file has now been moved into the staging area. And so those changes, like there's no changes that exist in my working tree that are to compare to what is at my most current branch. We basically moved that file into the staging area, which git diff is not comparing. It's comparing our working tree to our head pointer, which I kind of mentioned before is like our most recent commit that we're on right now, where we're located, where we're looking in our repository. Okay, so now I'll add and commit that. I'll commit that. And then okay, so now we've gone through git add, git rm, we've gone through unstaging, and we've gone through deleting changes in a file. Now we're going to do another exercise. So in our repo, I want you to here we go. And so we're going to hard set this at about, I don't know, 7 minutes or so. So try and get as far as you can in this series of commands with your partner. And, try and switch as we're going through this. If you weren't switching before, you can switch between different exercises if you want to. Okay, so I think we're going to start up again. Great job on those of you who finished. Totally okay if you didn't get there to the end. I have like a lot of exercises for us to be doing. Okay. Okay. So we're gonna transition into branching, which is a super powerful part of Git. This is one of the things that I think is really helpful to all collaborators. Yes.
Just a quick question.
Mm-hmm.
Can you expand between head and master?
I'm going to. That's what this is. Yeah, this is what this is going to be talking about. Don't worry. Okay. So I've been talking about how so in this very simple repository that we've been working in, we have something called a branch called master. Master is the default branch that Git made when we initialized our repository or when we cloned our repository from somebody else, the one that you've been looking at that I made for the class. So we can think, a branch itself, so I said master is a branch that we're looking at. A branch is a pointer to the most recent commit in that like branch history. And so as we update our history through time, if we make another commit from here, master is going to then point to this next commit that goes down the line. And so we can have multiple branches. So let's say we create a branch called testing off of master, but we haven't committed anything yet. There's going to be 2 pointers pointing to the same commit, and they each have a label. Again, we have master, and then we have a branch called testing, and they're both pointing to the same location. But how do we know if which branch we're on? Because we have these pointers that are these names that we've been talking about. We know we've been on master based on all of us have like this cool bash config setting that's telling us in our shell what branch we're on. It says master and then whether we've updated a file. There's something called head. And head is a pointer to what we're looking at, and it's specifically a pointer to this branch. So it's separate because head can point to a branch, but it can also point to a specific commit. So, for example, this diagram shows head pointing to master, which is the most recent commit. But we can do something called git checkout and move head to a previous commit. But master is still pointing to the tip of this branch. So what that ends up looking like, so also when we switch branches, it looks like this. But when we, I don't have an example of it. But okay, so I'll show you what it looks like if I draw it. So instead of having that diagram, if we check out to a previous commit, so we have and just imagine I'm writing these commit hashes, but it doesn't really matter since you know what this looks like. We have master, and we have testing. And then I'm going to show you what this looks like, but if we decide instead of having head pointed to a branch, which is this tip of this development branch, we can go back to a previous one we can pass a commit hash. So this is going to be what head looks like when I go back to. Okay, so I'll show you what this looks like. This is a special case called detached head state. So you may have seen this. Okay, so I'm going to say git log, and I showed you the one line before. Okay, so in our log, we can also see where head is pointing, okay? So right now, head is pointing to master, okay? So now I'm gonna say git checkout, and I'm gonna go to this commit 2 back. So D71, okay? Okay, so now Git says, okay, you're now in this detached head state. You've detached head from the branch that you were in, master, and it's detached from this tip of this working point. And it says, it gives us a little warning saying you can look around, but it's not a good idea to commit here. And that's because if we do start committing here, these labels, master and testing, are pointing to a specific location in our Git, in our .git folder. If we start committing off of here, this isn't associated with a branch. So if we commit off of this commit without branching, and then we make some commits here, and then we switch back to master, we don't have a way of going back to this other development work that we did because there's not a label associated with it, and we don't have a pointer to it. So the only way we can go back to it is if we happen to know the commit hash of the next 3 that we made. So it's not a good idea to commit from detached head state for this reason, because we need these pointers that point to all these development histories. Okay, so then it also tells us that if you do want to make this, like I was just talking about, you can do git checkout -p. I'll talk about exactly what that does in a second. So now if I do the one line again, so now I don't see head is pointing to master. Head is instead at this commit, this D7 that I checked out before, right? But I can't see any of the commits that I made after it because head is only recognizing the changes that go up to that commit. It doesn't know how to go like forward, right? So the way that we go back is we can say git checkout master. And then I can show you what the log looks like again. So again, I told you that master is this pointer to this history of this branch, the tip of this branch. And now head is pointing to master again. So I moved it from detached head state back into the point where it's supposed to be. Yep.
So what might you want to do if you went back? Like just look at a file from previous
Yeah, sometimes you want to look at it. Like maybe you know that you like wrote a function before that was really good that you liked, and you want to look at what that looks like. You can kind of inspect that. Maybe you're kind of looking like maybe you've realized that you went down a path that you don't like in your history, and so you want to go back to that point, but you want to figure out where it is, so you check out first, and you look around, and then you branch from it once you figure out which commit has the file versions that you like. Does that make sense? Yeah. And so then once you figure out what commit it would be, then you want to make a branch off of it, because you're saying, now I want to make a pointer from, like, with this history and continue off of it, right? Okay. So right now we have 1, and we can see our branch. We can type git branch, and this will tell us which branches exist in our local repository on our computer. And so right now I have 1 branch called master. If I type git branch and then I pass an argument, I'm going to make a new branch off of where I currently am. So I can say git branch, and then maybe I want to say, so we had this testing one before, so maybe I'm going to say testing. Okay, so now I can say git branch, and I have 2 branches, and git is still telling me which one I'm on. I'm on master, and here's testing, right? I can switch between branches, so we just use git checkout to move head from the tip of master to a previous commit. We can also use git checkout to switch head to point from, and I'll show you in the diagram, to switch from master to testing. So it's going to point instead to testing. Even though they're both pointing to the same commit, we might have some divergence at some point, right? But right now, they look the same because I haven't made any changes on either branch once I made these new branches.
Yeah, but before we learned that we can use checkout to revert the file. How does that fit in?
Yeah, so checkout, you can either do checkout to go to a previous working state of the repository itself, or of the file itself, or of a particular file if you pass it a file command. So you can actually say, I want to go back, let's say I know I like the previous version of a particular file. Like in this dissertation, maybe I liked the results when it was still empty and I want to bring it back. I can say git checkout and then the commit hash and then the file name, and I will bring that version of my file to my current working directory, just like I did So when we deleted the ones, that was a special case of git checkout where we're just bringing it back to the most recent commit, right? And we're bringing it back to head, but we can also bring it back to a previous commit if we want to. It's just if we don't pass any argument, then we say, it's only, if we don't pass the commit hash, then it's assuming it's the most recent commit.
Yeah.
Does that make sense?
Yeah.
Yeah. Okay. So now I have master and testing. I can check out, so which means I'm going to change the pointer from master to testing with git checkout. And now let's see what it looks like. Okay, so this is cool, right? Now let's look and see what the git log looks like. Okay, so now we have a little more information. Before we had head pointing to master and nothing else. Now we can see head is pointing to testing, and we know it's also on testing. It's pointing to testing because we know we're on the testing branch here. And also master. So this means both testing and master point to this commit hash, E4, 5, whatever the number, that like series of numbers is, right? That particular commit hash. So that's two commands. We can do git checkout, or we can do git branch and then followed by git checkout, or we can do it all as one command if we want to, and we can say git checkout -b, which means I want to create a new branch. I'm going to check out branch with this name, and I'm going to create it off of where I currently am. And let's say I'm going to make this one called appendices. So now it says switch to a new branch appendices, which means in this one line I created a branch and I switched to it, and I can check with log. And now I can see that there's an appendices, a testing, and a master. Yeah?
So I get that heads are pointed, but does that sort of imply that appendices, testing, and master are also pointers to that hash?
Yes. Yeah, exactly. They're all these are all pointing to this, but head is pointing specifically to the branch in this case. It's pointing to this pointer. And head, you can change whether it's pointing to this pointer or whether it's pointing to a commit. Does that make sense?
Yeah.
Okay. Yeah. Okay. So now we've done like a quick introduction on what branching looks like. I want you to, so right now I don't have any diverging history, but we're going to do a little example. We're going to do a work thing with our partners and do that. So we have another exercise. Here we go. Here we go. So do this with your partner. Again, green is in progress, blue is finished, pink is you need some help. Okay, great. Okay, so now we're getting a little used to git branching. Did everybody see that it was difficult to delete their branch when they tried to in the last command? Yeah? Okay, yeah. So Git helps us, right? I've been talking about this a little bit through the entire lesson, that Git tries to help us from ourselves because, as you can see, even with my dissertation, I'm messing up lots of stuff. So Git telling me, oh, you shouldn't delete this because they haven't been merged in any other place in the repository means that it has training wheels for me, right? So now we're going to get into something called merging. I just mentioned merging. So we started before this previous exercise with two branches pointing to the same commit, and then we started committing off of one of the branches that we were in, and that updated head and it updated that branch, and we could see changes, right? So instead of this like very simple diagram, then we have something like this. So we have maybe we have a testing branch that we added some commits off of, that we branched off of master, but then we switch back to master and head is pointing to master. So we can merge this so we can do something called a merge to incorporate changes from one branch into another. Git branching is very helpful for us in science because we can create an isolated environment to develop something, or write a part of our paper outside of the main development branch of whatever we're working in. In our own code, when we're working on our own thing, sometimes branching isn't as necessary. But as soon as we start collaborating with people, if there's a lot of updates to a branch, we're going to have to constantly update that in our local machine. So actually, some of you noticed when you did git log one line, as you were looking through the history, there were additional branches that we didn't see in my example that I've been doing, because I initialized only on my local machine. But all of you cloned, and so there were 2 additional pointers that said origin head and origin master, right? And so that might be updated a lot outside of our own development. And so we can create these branches and then merge them back into master as we finish different features that are interesting to us. So when we merge it, it might change. And so we first might make a change to master, like a collaborator might update master with a commit. And then we can merge it. So we can switch to master and then merge testing into it, and it'll update our diagram. So let's try that. So first, so you already did this, but I'm gonna make an appendices document and add it and merge it. So first I'm gonna make sure everything is what I expect. Okay, so now I'm gonna add and I went into Vim, sorry. I should be using Atom. Sorry, everybody. Okay, so now I can say, so I'll go back to that next time. Sorry about that. So now I can say git status. Okay, so I have appendix A. And I'm gonna add and commit it. Okay, so now I can see that testing in master is in a different place at a different commit than appendices. I'm going to switch back to master and make a commit on master also. Let's see what's in here. Yeah, sorry, I almost did it again. It's really, muscle memory is very strong sometimes. Okay. Okay, so now I've saved that. Let's see what happened. Okay, so now I'll add and commit that. Telling you this is major feelings for me. Okay, so now I've made a commit on master and I've made a commit on appendices. So if I look at git log one line, I can see that master head is pointed to master, and I mentioned the cluster I hate, and I can see testing, but I can no longer see the appendices reference anymore. And that's because the appendices has now, we have two different commit histories for appendices and master. They diverge from each other. So now we want to incorporate, maybe I want to incorporate appendices into master. Like now I know this is what I want to do. So what we do is we can say git merge and then the branch name. So I'm going to say git merge appendices. And so Git automatically wants me to make a merge commit. We can avoid this by saying, I think, minus like no commit or something like that. But it's good when you're merging to kind of make these merge commits so you know when they're happening. And that way you see this reference through your history, like this is when I merged this branch. So I'm just going to leave it. So Git already says, oh, this is what I suggest that you make for this git commit message. So I'm going to save that. And I'll exit out. Okay, so now it says git merge appendices, and it says merge made by this particular strategy, and it says that 2 lines of appendix A have been merged into master. So now if I say git log, I can see that the appendices branch is a little bit farther back in my history because now it's based on the time that I made the commit, and I made the appendices commit before I made the cluster commit about the one I hated, right? So it just shows up in the log as a linear based on time in this particular case. And then I can see the commit that was made in master about the cluster that I hate also. But because the appendices history has been added, now I can see the appendices pointer also, because that history is now associated with master also. And then I also have my merge commit of merging the branch appendices into master. Okay, so now we're going to do another exercise with merging. Okay, so again, just like we've been doing, put a blue one when you're finished. And let me know if you need help. Okay, everybody, we're going to start on the next section. Okay, so sometimes when we're doing merging, we can run into conflicts, which means that we've made changes. So we just had ideally with the changes that we just made, we had no conflicts, that the merge was very easy because we changed 2 completely different files. So Git said, okay, well, master and whatever branch we were on, in my case, I was doing appendices. Appendices and master are modified 2 different places and 2 different files. So there was no problem. Git was like, I can incorporate both of these very easily. So sometimes we might have a case where maybe a collaborator of ours has changed the exact same part of a file that we changed. Maybe we both recognized that a sentence needed to be rephrased, but we rephrased it differently. Then we have merge conflicts. And this is something that happens a lot in Git. So learning how to resolve merge conflicts is really useful for collaboration. So I'm going to make a quick example on 2 different branches of changing the same file in the same place, and then I'm going to show you what it looks like to do a conflict resolution on the command line. Okay, so I made the testing branch, and I have master, but I'm going to, since master is really updated, I'm going to branch off of that, and let's see, what do we want to say? Let's keep going down this cluster sadness that I was doing before. Okay, so maybe I'll also add something in appendix A. Both will change appendix A. So on cluster, I'm gonna okay. Okay, so I've changed line 4. I'm going to save and add and commit that. Okay, so now we see that, okay, that file looks like it did before. I'm changing line 4 again, and I'm going to say something like, I'm glad you're all appreciating these. That's great. Okay, so now I have saved that. Now I'm going to say git status. Okay. Let's see. Okay, so now I have master and I have this other branch cluster that I made that I know is going to have a conflict. Now I'm going to try and merge cluster into master and see what happens. Okay, so Git first of all tries to auto merge appendix A, and then it says there's a content conflict, and that's specifically a merge conflict in appendix A, and then it says it recorded a pre-image, and that it says Git basically says, I'm very smart. I'm not as smart as a human. Please go into this file and tell me what I should be committing and merging together. So let's open now Appendix A and see what it looks like. Okay, so now we have like this special thing. I did not know Adam did this for this color coding. This looks very cool. I see we're all on this walk together. I'm going to tell you, Vim doesn't do this. It does not look this cool. So we have, it also says our changes and their changes, which their changes, this is associated with the branch cluster. And this is what the sentence looks like on head/master, right? Okay. So maybe actually I've realized I like both mine and my collaborators' conflicts. So I'm just actually I'm not gonna delete one or the other. I'm just gonna put all of this together. So to make sure this conflict resolution works, I have to delete all these special characters. So the equal signs in between the head, between each branch has to be deleted. And then I also have to delete these, sort of pointers to these branch references. So, okay, I'm like, I like both of these, so I'm gonna do that. I did not, this is really cool with those buttons, but I'm not gonna do it that way. So now it seems like it's good, and also I've realized, okay, well, I also don't want a new line. I don't want like a space there. So I'm gonna actually add another thing in this. So I'll save it. Huh? Did I not delete it? Oh, there's no equal sign. These are button. Oh. These are button things. The equal signs only happen between the two things. I'm gonna just not go. I'm not gonna go too deep into Atom merge things. I'm just gonna show you what it looks like to delete this. You can investigate this on your own and like what pushing these buttons does, but I'm just gonna show you what it looks like, because what I've done is it doesn't matter which text editor you're in. Like deleting this stuff, you could do in Vim, you could do this in Emacs, you could do this in Nano. But these buttons are unique to Atom, so I'm not going to go into it. Okay, so now I'm going to save it, and now I'm going to say git status and spell it right. Okay, so now it says, okay, you have unmerged paths. And it says, so now it says, okay, I can tell that you've made a resolution because you don't have these arrows in the file anymore, and you can add the file to mark the resolution. So now I know I want it. So I know this is in the final form that I want it. Now I can say git status. And now it says changes to be committed. So in order to do this, I have to actually commit and make a merge commit myself. But because I had to do this conflict resolution, Git doesn't automatically just say merging branch into something else. We might say incorporating master changes over something else. So I'm going to just mention that I'm doing both, but including sentences from both. So -m. And so it also is saying git commit, use git commit to conclude merge. We can also, if we realize, I just want to point this out, but I'm not going to show it, that we can abort a merge when in the middle of this. So we can start editing a file and then realize, actually, I don't want to do this merge yet. I'm not ready. Maybe I want to look at my collaborators' changes a little bit more. We can abort the merge with git merge -- abort. And that will go back, and it'll bring you back to master with your change on master and your change on cluster. Okay, so now I'm going to commit it, and I'm going to say, great. So now I've resolved it. Now we can look at the log, and I can see that cluster is in my history now, whereas if I had looked before, it wouldn't have been in my history. Okay, so now I have set up a branch for you. So in the exercises, I want you to all do a conflict resolution yourself also. I have made a branch called, is this the right one? Nope. It's in exercises. I made a branch called authors, and that is going to have a conflict with master. If you check out, so this branch you haven't looked at and it's not showing up, but that's because it's associated with what you cloned from. Once you check it out, it will be locally tracking. And we'll talk a little bit about locals and remotes in a second, but I want you to do the conflict resolution first. So try and do this with your partner and put up the blue when you're done. Collaboration, right before we finish. Yep. Sorry, I keep forgetting about this microphone. I want to get a little bit to talk about remotes. So we've talked, so now some of you are asking very good questions about remotes and the references to remotes and how those are different from what we see in our history. So first of all, I wanted to point out that remote collaboration is extremely powerful. Everything we've done right now has been on our local machine except when we said git clone. That's the only time we directly interacted with GitHub, and we said I want to clone this repository and put all the references and all of the history onto my local machine. All the commands we use so far are not interacting with GitHub at all. Now, so we can do things like move our changes up to GitHub. So some of you have noticed that in the git log one line, there are pointers to things that are not the branches that you've made. And it says origin /head or origin /one line. So those are references to something called remote called origin. Origin is Git's default for a remote. So we can see git remote just like we can with branch with git remote. And since I did a git init on the command line, I'm showing you a different repository with different history just to show you how you investigate remotes. So that's why I've switched out of the dissertation repo that we were just looking at. So now I have a git remote. Oh, sorry. I want to go into the Rust one. So I can say git remote. And I can say, okay, there's something called origin. This is the only remote that's associated with my repository. I can say git branch, which some of you were looking at. And I have one branch called master. Now, the remote itself also has its own set of branches. And these branches can be whatever I pushed up to this repository. It can be what my collaborators pushed up to that repository. So we can see remote branches as well with git branch -a. So we can see all the references to the remotes, and we can see that origin's head is pointed to origin master. And then we can see these other remotes listed that way. We can also have multiple remotes, but right now I'll first talk about one and then we can talk about multiple ones. So I know it's called origin. Maybe I don't remember where it's from. Maybe I cloned this a long time ago. So I know it's called origin. We can do a little more verbose with git remote -v. And I can see, oh, this is located at this particular URL that I cloned from. So if any of you do git remote -v on the repository that you have, it's going to be associated with it's going to be github.com/Munkum and then the ASPP summer school. Now, the problem is you clone directly from my user profile. And GitHub sets it up so that nobody can push to your repositories unless you give them permission to. So if any of you tried to put your changes up on my remote, Git would throw an error. So what we do is we create forks. Forks are like copies of Git repositories, but that solely exist in the GitHub world. And the nice thing about forks is that you don't need permission from me to make a fork, unless I've done some crazy config settings, but don't worry about that. So unless I prevent you from somehow making a fork, you don't need permission. You can fork it, and then the exact same repository will be made under your user account, and that then is something that you do have push permissions to. So what we're going to do for the next exercise, I'm gonna first show you how this works. But so, right, a lot of people end up cloning a repository to build from source, and then they realize that there's a fix that they want to make, but their origin is set to whatever the working clone was. So like maybe matplotlib's core master, and now you want to make a fork of matplotlib so that way you can make a change to it and then push up to that. And then the way that we incorporate all of these different changes that somebody might submit to us is we submit a pull request. So we're saying, I've made these changes, I've pushed them up to my remote, and I want to ask you to incorporate them into yours. So this is the way that you can get your changes into my repository without having direct push permissions to me. So actually I should show you. Okay, so I mentioned that we would have this origin, and origin is usually set to your local user profile. So what we do to make a fork is we go to GitHub, and let's say I want to make a fork. I already have a fork of matplotlib, so I just want to show you what this looks like. Does anybody have a favorite project? Maybe a bio-related one that I won't have because I obviously like neutrons.
Trinity.
Trinity? Okay. Is it this one?
Oh, no idea.
RNA-seq.
Yeah, there we go. That one.
This one? This one? Okay. Oh, cool. Pearl. That sounds awesome. Yes. Okay. So we can directly clone, which is what you did with me with this clone or download button, and that's how you get the URL. But I just pasted the URL in our thing. I can also create a fork, and then I'm associated with a bunch of organizations, but I'm gonna fork onto my user profile Munkum. Okay, it's gonna be cool. Yeah, awesome. Okay. So I'm going to show you what it looks like to change to, now you've seen me fork. I'm going to show you what it looks like if I directly clone this. And then I want to change it, and I want to update the names of these remotes to be associated with my user profile instead. So I'm going to go back, say git clone. Let's hope this goes faster than before. Oh, well, that's okay. No. So now, again, I didn't clone my fork, which is normally what you would do if you make a fork. You want to clone directly from your fork. But I'm trying to talk about the workflow where you maybe clone somebody else's work and then realize that you wanted to make a fork and push to your own fork. And so because we only have one remote, this is like going super fast. Sorry, everybody. Okay, I'm just going to show you on a different one that's not taking a while. But just imagine I'm changing two different ones. So that way this goes a little quicker. So I'm going to, so we can remove an existing remote by saying, and then, so I'll first show you. So then we can say git rm origin. Oh, git remote. Okay, now I don't have a remote called origin anymore because I deleted it. So let's say, so let's say that was like a different one. So now I want to add an origin. So I can say git remote add, and then I say the remote name, and then I say a URL. Then I can add another remote, and this, so in the case of you forking somebody else's repository, you can put their username as a remote name, and that way you can incorporate their changes into your local branch too. So I have an organization that other thing came from, which is this data exploration lab. So I'm going to get the URL there, and I'm going to call it git remote add DXL. And then I can say git remote -v. and I can see 2 different remotes. And then if I say git branch -a, oh wait, do I have to do a pull? Oh, yes, git fetch. We pull changes down with git fetch, so I can say, so now this is getting me all the references from a new remote that I added, because when you clone, the references come with it, but if you delete a remote and then add a new one, you've just added a URL. It doesn't know the references of that until you fetch them. And so now I can say git branch -a, and now I can see all of the remote tracking branches associated with my friend DXL, and then I can say git fetch Munkum. Oh, git fetch origin, because that's what I named it. And now it has these new branches, and then I can say git branch -a. And now I can see all origin references and all the DXL references. So then I can push up to my origin if I want to. I can make a change, and I can then compare changes in the GitHub GUI. So I'm going to show you with a branch sort of what that looks like. Oh, not in this one. Actually, let's just go into an exercise so you can do this a little bit on your own, and then we'll go to lunch, right? Yeah. But maybe only 5 minutes on the exercise, or what do you think?
Have you done, sorry, have you mentioned the pull request or not?
Well, okay, so I can, so once you, okay, that's true. I will, yes, I can show them a pull request. I'm just trying to think of a good example of submitting one, because I haven't pushed to a remote. Oh, actually, I can. I'll show you what it looks like. I know what I can do. Good. So I mentioned that, okay, so when we can bring changes down. I love cats, hello. When I pull changes down to, where's our paper? So I can, so when you fetch changes, you can have, when you fetch all these remote tracking things into your local, you have to then merge them into your current working branch if you want them, unless you have never checked it out before. But if you have, like, let's say you had the authors branch and then I pushed up to it, then you would have to fetch the changes and then merge them into your branch, because you can't just, you're already checked out on it, but I maybe have a commit that you already pulled, or that you already, that you haven't incorporated into your local. Fetching and merging together is called git pull. And so a pull request is a special feature of GitHub where you ask somebody to bring features into the working master branch. So if I wanted, I can look at my authors branch, the one that we were looking at, and it can, so this is exactly what we just did on the command line, but instead we can submit a pull request. So instead of fetching and merging, instead of getting the changes, like checking out 2 different branches on our local machine, and then merging them manually on the command line, we can also compare 2 branches on GitHub and submit a pull request. But the thing is, the nice thing about pull requests is it doesn't have to be on the same repository. You can submit a pull request from your user profile to a remote. So you could say, so this is a little hard because I don't have an upstream in this example, but or like one that I've cloned from, but if I wanted, I could say, if there was another one that we had, you could say, I want to submit a pull request. And here it says the base and compare. And because I'm in the same, since I'm in the same repository where it's happening, it just is a branch name. But if you're doing it from your user profile to an upstream like matplotlib, it'll say your username / branch to, so you want to compare like your username / branch to like matplotlib / master. Okay, so that's what submitting a pull request looks like. Most projects have contribution guidelines to submit pull requests. So you want to follow those. There's often very good documentation on what makes a good pull request. But you also, with like writing a paper or something like that, a pull request can be much more free than when you're doing code-based pull requests. So I could create this pull request if I wanted. And it says can't automatically merge. There was like that thing. and it's saying it has conflicts. And if I was like afraid of Vim, for example, and I didn't have Atom on my computer, I can resolve conflicts in the Git GUI exactly the same way that we just did, which is pretty cool. So I have a example that you can start on, and we won't go too far into this, but I want you to log into your, whoever set their email on the example when we first started. I want you to log into your GitHub account, change the remote name. So delete the remote tracking Munkum, fork the original one onto your user profile, push the changes up to yours, all the changes that you made when you were doing this up to your local fork, and then try and submit a pull request to mine if you can. And we'll try and do this for the next, I don't know, 5 or 10 minutes? Yeah, sorry, this is going over. So I know you're all probably hungry. So try it. I know I didn't show you any of this command line, but this is really the power of collaboration with Git and GitHub. Okay, so I want to show everybody what it looks like now when you're doing collaboration. So some groups have already gotten and finished this. I just want to show you what it looks like from the perspective of a collaborator, what it looks like when you get a pull request on your repository. So I have some insightful changes pull request, and also Jessica and Art's brilliant work, which, I mean, clearly I want to merge that, right? So I'm going to look at this pull request, and GitHub has a few things. So we can see, this is amazing, great, really love it. So we can see that there's 7 commits. We can see all of the commit messages and the hashes associated with them, just like we can with the log. We can also use the Git GUI to inspect the files changed, so we don't necessarily have to look at that locally. We can see, oh, how did they resolve these changes? What does this look like? Oh, this looks great. And yes, I believe that your research will back it up. That's going to be great. Okay, so I can say, maybe later, in a different lesson, you might hear about continuous integration. This particular repository does not have continuous integration, so there's no checks that are happening as a result of this pull request, but that might happen depending on what you're submitting to. And it says this branch has no conflicts with the base branch. So Jessica and Albert, Jessica and Art, I just want to show, I want you I'm going to respond to you, but I'm going to be really nitpicky. And I'm going to say, and so then I can comment, and I can also start a review, but I'm just going to comment and show you what this looks like. So I'm going to comment, and I'm going to say, can you tell me more about your research? So can you make an addition to the thing about backing up your research, add and commit that, and then push it back up to your remote, and let's see what it looks like when that happens. And also, I always like to add cool celebration emojis when people submit stuff to my repo. Why is this? There we go. See? Oh, it's so happy. Yeah, you can do whatever you want. Just like submit, you can submit whatever. I'm just going to show what it looks like if somebody pushes after you comment on the pull request. Because often when you're submitting to these remotes, people can be very picky, depending on, maybe your collaborator, you're writing a paper, there's no problem. But maybe, maybe you wrote Python in the way that makes sense to you, but it doesn't abide by the style guide of the particular repository you want to contribute to. Or maybe, something happened that was just like a little different and they want you to update it. This is what this is going to look like. Also, sweet name, Jethro the cat. Very cool. Yeah, I love it. Very good. Mm-hmm. Yeah. Mm-hmm. Yeah, love it. Yeah. So also, I've made a comment on this, and this is the start of a review on GitHub. And something that is like very helpful for collaboration is if you're a strong user of a package, but you maybe don't contribute to it, if you haven't made direct commits, you can still review pull requests, and you can still look at what people are doing and say, this is really helpful to me, and this is something I've been looking for a long time. And it's very helpful because core developers, get very deep in the code and sometimes don't remember what it's like to be a new user of a project. And so if you really care about some projects that you're working with, consider adding some reviews to pull requests that people are submitting. Or you can submit issues and say, this doesn't exactly make sense to me. Can we update the documentation so it's clearer or something like that? And so, the issues I can show while they are doing that. So there's also an issues tab up here. And you can start an issue. And it basically is like, we can say, and so then somebody can see it and see that there's an issue on this repository. And so then, that can be resolved. Well, also amazing, really loving it, loving these pull requests. Okay, so now we can see that a change has been updated since I asked for this commit. And I said, can you tell me more about your research? So I can actually click on that commit and I can see what that looks like. This is so good, so good. Okay, well, I think I'm sold on that. So I'm going to review that and I'm just going to approve. No changes, I'm going to say. Yeah, you've definitely convinced me. I'll also add a thumbs up to my own reaction. And then I will merge the pull request. And it'll say confirm merge. And now GitHub is updated. So instead of the pull request being open with that green open sign, it now says merge, which means that this pull request has been merged into my master branch. Yes. Yeah, so now, so this is what the pull request looks like. If I go back to the main part of the repository, I can see first of all I can see my merge pull request, and we can see here like the Jessica and Art's brilliant work, and then we can look at 14 commits. And we can see all of the commits that Jessica and Art added, and then also mine from the beginning of this. Okay? So this is like a very basic example of submitting a pull request. I have a challenge for you if you really feel like you want to get some extra cool credit while you're here. Nell and I put together some examples of matplotlib documentation that could be improved. I'm going to link it in the Zulip chat. And if you do decide to submit this pull request, please tell us so that way we can start reviewing it right away, because that way it won't just sit there. Not extra good things. You can look at that if you want to. But so in the exercises, there is the collaborators exercise, and I have a whole series of things that you could do if you want to contribute to Matplotlib while you're here. So I'll link the Excel spreadsheet with the examples that could be improved, so that way you can look through them. Feel free to do it, but if not, totally understandable also. Thank you, everybody. I really appreciate it. If you have any questions about Git, I'm happy to talk to you about them afterwards. If there's a quick one I can answer now. Yes?
Did you guys put up the previous exercise so we can just finish it off?
This one? Or
Section 6.
oh, section 6? Yeah, sure. So yeah, this particular lesson, huh?
They should probably just clone that repo and have all.
Yeah, that's a great idea. So this particular repo, you can see that this is part of the group ASPP, and then you can see that there's a Git and GitHub repository. And it has, I've talked through a lot of stuff, but I wrote a lot of notes on all of the things that we did in each of these modules today. And then in exercises, all the exercises are here too. So you can clone this repository if you go to this URL and then you'll have the exercise on your machine. Okay? Thank you, everybody. I really appreciate it, and I'm happy to talk to you about Git afterwards.